Welcome to Study Loop.
Hello students. So in the A part we have to find the molarity, which can be found out as we know that pH is minus log of concentration of H positive ion. If we have to write the molarity of H positive ion, that is concentration, so we can get when log is taken to this side, it becomes 10 raised to power minus pH. Now we just have to put its value. So for first solution, for first solution concentration of H positive ions comes out to be, the molarity comes out to 10 raised to power minus pH. pH is given as 3.11, and when we solve it we get 0.00077 molar. Similarly, for second solution, concentration that is molarity comes out to be 10 raised to power minus, pH is 4.47, and when we solve it, it comes out to be 0.00034 molar. And when we compare these two acids, on comparing, solution becomes less acidic. Then for the B part, similarly we are given two basic solutions and we have to find the pOH. So pOH is found out by negative logarithm of concentration of OH negative ions, and also for pH can be calculated from it by subtracting this pOH from 14. Then we get the pH of the solution. So for the first solution, we are given with, like, pOH is can be calculated as 14 minus pH is given to us as 12.16. Then pOH comes out to be 1.39, and for the concentration of OH and negative ions, we can write 10 raised to power minus 1.39, and it comes out to be 0.041 molar. Then for second solution, our pOH can be calculated as 14 minus pH is given to us as 11.46, and when we solve this, it comes out to be 2.54. Then the concentration of OH negative ions for this second solution is calculated as 10 raised to power minus 2.54, and this, when we solve, comes out to be 0.0029 molar. So when we compare these two solutions, it comes out to be less basic. Then in the part C, the unique ability of the acid is to resist the change in the pH when small amount of acid and bases is added. To resist the change on addition of acid and base, and this is because the small amount of acid and conjugate base are present in the solution. That's why it will resist the change in addition of change in the pH on addition of acid and bases in the solution. And for the D part, a difference in the pH of buffers and acid is due to the presence of both weak acid and its conjugate base, which allows them to resist changes. Difference in pH in buffers is due to, in buffers and acid is due to the presence of both weak acid and its conjugate base, which resists the change in its pH. And for the E part, we have so among the two, the buffer 1 has more or greater buffering capacity because it shows smaller changes in its pH when acid or base is added as compared to the second. And for the F part, we know by using the Henderson-Hasselbalch equation, we can find the pH of a buffer as by using this formula log of concentration of its conjugate base and its acid. By using this formula, we can find its pH of a buffer, and so our final answer comes out to be. So in this way, we can find these solutions of the corresponding parts of this question. I hope this solution is useful to you. Thank you.